Okay, today we're going to talk about Algebra 1, Chapter 6, Section 1, which is looking at exponent rules to help make life with exponents a little bit easier. Now, we're going to start each rule by looking at how do I solve this without the exponent rules, so that way we know what expansion looks like, and if you ever forget the rules, how to come up with the rules. Because that's one of the important things in algebra. We don't expect you to remember this in 20 years, but if you have to encounter it later, you know how to figure out those rules. Or, in 5 months. Okay, so the first problem we have is we have x squared times x to the third. So we're going to start off with x squared, which really means x times x. So I'm multiplying two x's. And then we have an x to the third. So we're multiplying x squared times x to the third, so that means I'm multiplying three x's. And when I'm multiplying all of those x's together, we get our final answer. So how many x's altogether are we multiplying? Well, there's 1, 2, 3, 4, 5, and so this becomes x to the fifth. And so how do we figure out the rule? Well, when I'm multiplying the x's, so they have the same base of x, those exponents 2 and 3, how do I get the number 5? Well, 2 times 3 doesn't give me 5, but 2 plus 3 does. So when I'm multiplying monomials that have that same base, we're going to add our exponents. So x to the a times x to the b is really x to the a plus b. So we end up adding those exponents. And that's our rule. So we're going to use that to work out some problems. So on our next problem, we have 2x to the third times 3x to the fifth. So the 2 and the 3 aren't the same number. They're not the same bases. So I multiply them because that's what we're doing. We're multiplying things together. So we have a 2 times 3. And then the x's have the same base. So I have an x, and I can combine them into one x. But to figure out that exponent, I add those. So 3, oops, let's go ahead and write that so it actually looks like a 3. 3 plus 5. And so now we end up with an answer of 6x to the 8th. And usually in algebra, I get this thing, oh, do I have to write out the work, how I get it? I just know the answer. And I say yes. Because when you're working with just this one rule, it's really easy to not show work. But we have 6 different rules with exponents, and you're going to get them all mixed up, just like working with positive and negative numbers. Students mix up all the time the rule for multiplying positive and negative numbers and the rules for adding positive and negative numbers because the rules are different. And so if you don't write out your work, you're never going to really learn the rules, and you're going to mix it up, and you're going to feel like, oh yeah, I know what I'm doing, and you've mixed up your rules and you've got a 0 on your test, which is no fun. So our next problem, we have negative 4 times negative 4y to the fourth times 6y to the first. So when there's no exponent, there's really a 1 there as an exponent that we're going to use. So this is going to be negative 4 times 6. And then I have y to the fourth. And then I have just a y, which means that it's really y to the first. So I add those together, multiply the regular numbers, so negative 24. I add those exponents on the same base, and I get y to the fifth. And that's our answer. So now we're going to move on to the next problem, getting a little bit more complicated because now we have more variables. But again, with our regular numbers, we're still timesing 10 times 3. And then I'm looking at my x's, so x to the second and an x to the first because it's just x. So I add those exponents. And then I'm looking at the y, so y to the sixth and a y to the fifth, so I add those up. And this is going to give me an answer of 30 x to the third, y to the 11th. And that's our answer. So one more before we head on to the next rule. So now we have a 9 and a negative, which is really negative 1. So this is a 9 times negative 1. And then I have an x to the fifth and an x to the seventh, so I add those exponents. And then I have a y and a y to the second and a y to the third, so I add those exponents. And this gives me an answer of 9 times negative 1 is negative 9. X to the 5 plus 7 is 12. And y to the 2 plus 3 gives me 5. And there's our solution. Okay, so now we're moving on to our next rule. And our problem to help us figure out what is that rule really is 2x to the second, and then that whole thing inside the parentheses is being raised to the fourth power. So that means that whole parentheses is being multiplied 4 times. So I'm going to go ahead and write that out. So 2x squared, and then 2x squared, that's 2 of them, and then times 2x squared, and then times 2x squared. And you can even continue working this out, breaking it down, expanding it even more. And technically, if we were to fully expand, when it says expand, you're supposed to fully expand. So this should look like 2 times 2 times 2 times 2 times x 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 times x. But we're going to assume that you learned the last rule pretty well, and we're going to go on to this. So we have 2 being multiplied 4 times, so this ended up 2 to the fourth. And then we have x to the second, x to the second, x to the second. So let's count how many x's we have. We have 2, 4, 6, 8 x's. And so this would kind of help us figure out our rule. So that 4 actually ended up being distributed to the 2 and to the x. So we became 2 to the fourth and 2 and x to the eighth. But how did we get 8? We multiplied that 4 times 2. So when we raise a monomial to a power, we distribute the exponent to each base, and then we multiply those exponents. So this one, when we distribute in the exponent, and when we distribute, we're multiplying. Now, technically, you should not leave your answer like this, so I'm going to go ahead and finish this one out. We have 2 to the fourth, which is a value we can actually calculate, so it is our responsibility to actually calculate that. So let's think about this. 2 times 2 is 4. Oops. 4 times 2 is 8. 8 times 2 is 16. So this actually ends up being 16 x to the 8th power. So what does this mean for us in our rule? If I have x to the a, y to the b, and the whole thing is being raised to the c power, I distribute that exponent into the x and y. So this becomes x a times c and y to the b times c. And that's our rule. So we're going to use that now on our problems coming up. So now we have 3x to the fifth to the fourth power. So we're going to distribute that 4 to the 3 and to the x. So I have 3 to the 1 times 4, because remember there's really an invisible 1 there. And then x to the 5 times 4. So this is going to give me 3 to the 4th times x to the 20th. And then we can actually calculate out 3 to the 4th. So I'm multiplying 3 4 times. So 3 times 3 is 9, times 3 is 27, times 3 again is 81. So this becomes 81 x to the 20th, and that's our answer. So now we're going to move to the next problem, and we're going to go ahead and distribute this 3. Wow, that's kind of bright. To the 6. We're going to distribute the 3 to the x, and we're going to distribute the 3 to the y. So this is going to be 6 to the 1 times 3. This is going to be x to the 2 times 3. And then y, and there was no initial exponent, so that's y to the 1 times 3. And so this is going to give us 6 to the third is 6 times 6 times 6. So let's see, 36 times 6. So 6 times 6, 36. Carry the 3. 6 times 3 is 18, plus 3 is 21. And that gives me 216. And then we have an x to the 6th and a y to the 3rd. And there's our answer for that problem. So now we're going to move to the next one. We're going to distribute the 5 to the 2, to the x, and to the 7. So this becomes 2 to the 5th, x to the 2 times 5, y to the 7 times 5. So now we have to calculate 2 to the 5th. So let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 one more is 32. And this is x to the 10th and y to the 35th. And then our last one, we're going to go ahead and distribute the 4 to the negative, to the x, and to the y. So the negative is really the number -1. So this is -1 to the 4th power. And I want to change my color because I don't like doing the same color twice. Okay, and then I have x to the 7th times 4 because I distributed, and y to the 3 times 4 because I distributed. And so this gives me -1 times -1, which is 1, times -1 is -1, times -1 again is +1. So this is a +1, x to the 28, and y to the 12. And that is our solution. So we just have 2 more problems that combine the 2 rules and allows us to talk about order of operations. So we're going to go ahead and move down to a different color here. Yeah, looks like we have green. Good. And so the idea is that we have to distribute an exponent before we can start combining by multiplication. So, and the multiplication rule means that we add exponents. So I have to distribute this 2 inside first. But I can't forget about this 2x to the 3rd. So I'm going to write it here so I don't forget about it. And then I'm going to distribute the 2 to the 3. So it's 3 squared. I'm going to distribute the 2 to the x. So that's x to the 5 times 2. And so this is going to give me 2x to the 3rd plus 9 x to the 10th. Not plus. Sorry about that. So 2x to the 3rd times 3 squared, which was 9, and then x to the 5 times 2, which is 10. So now that we've gotten rid of those parentheses, we're down to just a multiplication problem. I can multiply my regular numbers. 2 times 9 is 18. And I can combine those x's, and since this is multiplication, I add the exponents. So 3 plus 10 gives me an answer of 18 x to the 13th. And that is our final solution. Okay, so our next problem, we're doing the same idea. We're going to go ahead and distribute this exponent first. So the 3 goes to the -2, to the x, and to the y. So this 4x, y to the 5th is chilling. I'm going to go ahead and put a 1 with that x so I don't forget that it actually does have an exponent. And then that's going to be times by, okay, we have a -2 to the 3rd power. And then we have an x to the 2 times 3, and then we have a y to the 4 times 3. So now we have to go ahead and simplify this first before I can start dealing with that 4x to the 1st, y to the 5th. So 4x to the 1st, y to the 5th. I keep writing it because I don't want to forget about it. And then that's going to be times, okay, -2 to the 3rd becomes -2 times -2 is 4, times -2 is -8. And then we have x to the 6th, y to the 12th. And so now we can go ahead and do that multiplication. So 4 times -8 gives us -32. And then we have x to the 1st and x to the 6th. So 1 plus 6 and y to the 5 plus 12. So when we multiply bases, which is what that symbol is telling us there, we add those exponents. And so this gives us a final answer of -32. My pen's going funky. X to the 7th and y to the 5th, y to the 17th, sorry. And that's our final answer. Okay, so we'll see you next time for our next set of rules. And then we'll be preparing for the final.